All right, I'm gonna let him in.
Hello, everyone, and welcome. We're just going to wait a couple minutes to allow everybody to join. So we'll probably start in about 2 to 3 minutes. And another welcome for everyone who is still joining us. We're going to get started in about a minute just so that we can give everybody some time to get on. All right, well, officially, welcome everybody. My name is Molly Simons, and I am the Marketing and Program Development Fellow here at CCHRC. Thank you so much for joining us. This is our second class in our Fall Clean Energy class series, Harnessing Solar Power in Cold Climates. We do have one more class in this series. It's about biomass energy. Next Tuesday, the 22nd, it's offered at the same time. If you want to learn more, you can head over to our website at cchrc.org, or I think we're going to put the link in the chat soon so everyone can access that. And these classes are generously sponsored by the Golden Valley Electric Association. We will have a question and answer section after the presentation. So if you have a question, feel free to put it in the chat or save it, and we will get to all of the questions at the end. Our instructor today is Mark Bielefeld. Mark is an experienced project manager who currently works as the land manager for Choggiung Limited. Mark has seen his own success with solar power and is passionate about the sustained, profitable future that solar has to offer. We're really excited to have Mark here with us, and we can't wait to learn from him. Thanks so much for being here, Mark. Oh, I think you're muted.
Hi, thank you for having me. I really enjoy a topic like this. That's one of the reasons I joined the instructor team at UAF to learn how to instruct solar classes. Like you said, I do have some experiences. One is kind of an anomaly. I was able to save, well, has the potential of saving $16,000 a year in fuel costs for the organization which I work utilizing solar energy. Uh, so we get started.
Sounds good.
All right, let's share my screen. Okay, move you guys out of my way here too. All right, so this is going to be focused on residential solar, basically getting started with sustainable energy. Again, it's a passion of mine. The experiences that I have, I actually installed a solar in a FedEx van, so it's remote, it's off grid. I've installed stuff on cabins, and I'm currently in a project out in the Lightning Gate right now. Uh, the customer actually purchased his solar system kind of backwards. He's starting with batteries and generator first, and then going to get his panels, but we're going to get him on the right track here shortly. So let's move on. Uh, Today's class, we're going to talk about the benefits of solar, uh, the types of solar systems that are out there, the installation process, some of the financial incentives that are available to us right now, and then tips on selecting the right installer. Why go solar? Uh, these are some of the reasons I came up with, because I too we're in the same seat as you, wondering, do I need solar? What can it do for me? Well, first of all, it can lower your energy bills. You can generate your own electricity, and you're going to have the potential of reducing your monthly utility costs. Energy independence, which means you can control your energy. For instance, in some of my applications, I've included strictly 12-volt systems or just run off batteries. There's also what they call inverters that you can control your AC voltages, like your refrigerators and TVs. There's all sorts of types of combinations that are available to you out there. Uh, you will reduce the environmental impact. Basically, this doesn't burn fossil fuels. It harnesses the sun's power and generates electricity for your homes. In many cases, it will increase the value of your home when you want to sell it. It's because it's already installed. Uh, it is the way of the future, is some type of renewable energy, and solar right now is at the top of its game. Currently, the federal government has some incentives and rebates. For instance, the solar system that I recently installed at a cabin for our company, the purchase cost was around $12,000, but the federal government will relieve upwards of 30 to 40% of that, depending on the type of installation, in tax benefits. So if our company still owes $1,000 in taxes, then it would reduce that by 40 or 30%. And it's a reliable power source. The sun is always going to be there, and it's going to be able to benefit. We're going to be able to reap the benefits from that. So those are some of the reasons why we should go solar. We're going to go over the benefits of installing solar. None of these are in any certain order, but the reduction or eliminating of your electricity bill. By lowering your electricity bill, your system generates its own electricity, so it will eliminate or reduce, at a very minimum, reduce your electrical bill within different programs. One, you can totally cut off from the grid and generate your own power, or two, you can augment your grid power and utilize your solar generated energy, and if you need more, you can pull from the grid. So that's how you can reduce your bill. Again, it can increase your property value. You spent $6,000 on a $12,000 system, so you're already ahead of the game. But by the time you want to sell your house, you'll have this system in place, and people will want to purchase it based on the energy savings. You also have energy independence. Again, you can harness the sun's energy, and you can bring in the sun's energy and reduce your need for the local energy or the grid energy. And again, the tax incentive rebates. You're going to hear that quite a bit throughout the presentation. So some of the environmental benefits, it reduces greenhouse gas emissions. Solar energy produces no carbon emissions. There's no exhaust, there's no fossil fuels being burned. It's just taking the sun's energy and converting it into useful energy that you can use either with direct current, which is DC, or AC current, which is alternating current. It's generally running your refrigerators and televisions and things like that. You also have decreased air pollution by not having generators and power plants running your energy costs. Use solar as a instead of relying on fossil fuels, you use the sun. So there's less pollutants and sulfur in the air. Conserving natural resources. By using solar, it's a renewable resource. It's free to us. We just have to install the system, and then from that day forward, we'll be collecting solar energy. So we're not using up our fossil fuels that can be used in other applications somewhere else, compared to what the traditional power plants utilize. Lower ecological impact. Again, there's no fuel extraction or transportation costs to haul your solar to your house because it's already there. You have to think about, for instance, our oil fields in northern Alaska. We have to generate the power to get that stuff out. We ship it down to the lower 48. They use all types of natural resources to process it. Then they ship it back to us and in the form of it to our power plants to generate our electricity. For instance, in Dillingham, we use millions of gallons of fuel just to generate enough electricity for the 800 homes that are out there. And by using solar, you will reduce that energy need. And of course, the promotion of renewable energy, this is one of the ways of the future. So it kind of supports that. By us getting solar now, it will support that program in the future and development of that program. Here's a couple of common myths. Solar's too expensive. Yes, in past years it was, but now you can, once you figure out how many kilowatts you need or watts you need or the amount of energy you need to sustain your home, you'll find that the current price is roughly $3 to $5 per watt to be installed, which means if you have a 3,000 watt system, it'll cost you about $3,000 to get installed. Or excuse me, $12,000 to get installed 3 times in that area. So that it just depends on your location, of course, the cost of getting it to you, but that's the general consensus is about $3 to $5 in Alaska, depending on your location per watt. Solar panels don't work in cloudy weather. I can attest against that statement because, again, I'll just refer to the generator or the solar system I placed in rural Alaska up a river. When we didn't have solar, it was costing me $1,000 a week just for running the generator. Throughout the summer, this year our average temperature was 55 degrees. It was always overcast. I only turned on the generator towards the end of the season as the night starts creeping up on us again for the winter solstice. So the first month of operation of our camp upriver was $4,000 for just the generator costs, and for the next 3 months, it only cost me $19 in gas. So it's a huge savings, and it does work in cloudy weather. The radiation continues to pass through the clouds, just not as efficient. Maintenance, it's super complicated and expensive. Not necessarily. The components for solar electricity are enclosed in a box. It's been tested. Is it 100% foolproof? No, it's not. However, we don't maintain the stuff that's in the box. We don't maintain the wires. Those things are static and they stay in place. Really, the only maintenance that you have on solar at this point is just making sure your solar panels are clean. And what I do for upriver activities is basically just wash them in the spring, and they're efficient enough to keep my operation running at pennies on the dollar. And the other thing is, again, you can only use solar in the sun. No, I mean, granted, the solar is not going to work in the evenings. In Alaska, though, we have sunlight all the way through 2 o'clock in the morning. So yes, they will operate nearly 22 hours a day, 20 hours a day, depending on your location. in the summertime, or excuse me, in the wintertime, it lacks a little bit on the performance because the sunlight is shorter. There's a few different types of solar systems. I'm just going to briefly touch on those. One of the most probably popular ones is probably the lowest cost is what we call GridTie. It's a type of solar energy that's connected directly to our local utility, which requires, an agreement with the utility company and their policies to make sure it's compliant. However, it's connected to the utility. So what are the advantages of this? It's low upfront costs because has the least components. It basically has a solar panel and an inverter. You don't have any batteries or anything to worry about, and you're just connected to the local utility. And the inverter, what it does is harnesses the sun's, or the panel harnesses the sun's energy, sends it through the converter, which transposes it into the operating current of your current household. So this system it's made up of a solar panel, an inverter, the existing circuit panel, and the meter that you see on your house, and basically gets connected to the utility. What some organizations have, utility corporations have, is what they call net metering. So basically what that's telling you is that you can generate all the solar power that you want. It can run 100% of your household if your system is large enough or large enough to do that. However, if it's not big enough to do that, then you can actually pull power from the grid. The other thing is if you have a system that's larger than your house needs, you can actually put energy back into the grid, and basically you'll be compensated that in your next monthly bill. Are you going to have 100% paid for bill? Probably not, because there's still administrative cost. But what you can defray is your actual usage of electricity. In this system, there's no batteries required. So this is one of the misconceptions that I had prior to learning about solar. I thought once you have solar panels, you can run free of the world. You don't have to worry about anything. But in this case, because it's grid tied, and this is a huge safety aspect, what they do is if the grid goes down, say you have a blackout or the power goes out, so will your solar system. And the reason is because the linemen don't need you generating energy going back into the grid while they're trying to work on the line. They can control the grid from the outside, but they can't control it from your house. So these systems are required to shut down if the power on the grid is down. And because of the minimal components needed, this is probably one of the best as far as what I would use in a household, the best thing to use. So it brings us to the next one, which is OffGrid. OffGrid is exactly what I did for the cabin upriver. It's complete. You're totally autonomous to the grid system. It's complete energy independence. You have reliable power in a remote location because the sun is there, as long as you have batteries. Environmental benefits. You're not using the generators that are used in the old days, and there's no electricity bills. The only bill I had up front was the initial cost of the solar panel, but this year alone, I've already paid for my solar system. So now there's free of cost of any utilities. The disadvantage is it is a little more costly. There's a couple more components, which I'll go over. There's a little bit more complexity. There's, like I said, more components, so you'll have to know how to install it or have a professional install it. Again, the maintenance, in this case, we're introducing batteries. So depending on what type of battery you have, you may have to fill it with distilled water. And again, you still have to clean the panels off probably once a year, maybe twice a year, just depending on your environment. And of course, the snow, if there's snow built up on it, you would have to clean it off of that as well. But the batteries in this case are the biggest component that add to the costs and the maintenance of those batteries. And in this case, because you're not dependent on the grid or the utility, you really have to watch your energy usage. You might not have a system large enough, and if you're running incandescent light bulbs or a lot of refrigeration or freezers or air conditioners, you really have to manage your energy management. So that's why you want to have high efficiency equipment, high efficiency lighting, electricity items, and you're limited to certain backup. In this case, you can add a generator, and you can see within the what do you call it? Let me get my little laser pointer. Here we have a generator. There's a couple of different types of systems. You can have if it senses that the batteries are low, certain systems can start the generator up for you. You still have the inverter. We also introduced a charge controller. What this charge controller does is take the energy from the sun, from the solar panels, it goes through the charge controller down into the batteries. So what this charge controller is doing is it senses the charge capacity of your batteries, and either the high end, which if it's full, it's going to stop charging so the batteries don't blow up. And at the low end, so the batteries don't deplete themselves 100%, it will shut off the system. And you can use the generator through the inverter to actually charge the batteries as well. So if the charge controller senses that the batteries are low, it sends a signal out to the generator. The generator starts up and it will charge or power your house and charge the batteries at the same time. So now we have the best of two worlds. We call this the hybrid system, or it's a grid tied with battery backup. So again, this allows you to have energy independence. It's optimized energy use. It's got a cost savings, and it reduces the carbon footprints, many like the other systems. Again, one of the disadvantages to this system is the upfront cost. Now you introduce the battery and the charge controller, and sometimes you add a DC panel to run or a separate panel to run your important items such as refrigeration or maybe a medical piece of equipment or emergency lighting of some sort. So what this system is, it's a powered system connected to the grid. It also includes battery storage. During sunny days, the solar panel generates electricity, and then the batteries will continue that generated electricity through the inverter and run your house even at nighttime. So you can take advantage of certain power providers have what they call structured billing or something like that. Certain times of the day, their bills might be higher, so you want to use your energy during that period, and then where it's a low cost billing, then you'd want to use theirs to charge up your system. So it's a kind of a handoff, so you kind of save money in that direction. So in my case, if I had a house, I'm probably leaning towards the hybrid system, just because if the grid does go down, you can still have your emergency power through the battery system, and it won't affect the linemen out on the lines when they're trying to repair a down or an outage. And here's probably one of the most simplest systems, and this would be something you can use for a water pump or something like that. And what you can see in this diagram is a solar panel, a pump controller, which is just a switch. So you're basically charging the switch to turn on the pump that fills the water container. And you can have the water container run over. It doesn't have to stop, but during the daylight hours, it will fill your $500 to $1,000 water tank. I've seen in the lower 48 and maybe here in Alaska as well, but the roof venting, I've seen solar panels on top of the roof vents that basically power the fan on your roof to ventilate the attic spaces. So that's a cool application, I think. And one of the disadvantages, you can't really do too much with this. I mean, you can light a light, but you can only light it during the daylight hours. But again, it's just limited. There is no energy storage on here unless you build some type of hybrid system, and it's totally dependent on sunlight conditions. So as the cloud covers the solar system, or the night starts coming by, you'll see that the power of the pump slows down, and then once it becomes nightfall or totally blocked by the clouds, the pump will most likely not run. But it is something, maybe you have some livestock out there that needs to be fed with water, and you don't, in that way it'd be a good source of the pump. Types of mounting systems, it's very important. We'll go through a couple of these. So this is a roof mounted system. This is probably one of the most common you'll see around. One of the advantages, it takes advantage of the space of your roof. You can see on this garage, the person just put it on there. And again, it looks like he's cleared the snow off. And it's low installation cost. Basically, it's just a rack system that you install on your roof. You apply the panels to those and you're up and running. The biggest disadvantage is again, your roof has a lot of, you might have a chimney or might have a dormer on it. Just might be the shape of your roof. You have limited space as well. And you also have that potential of roof damage. A lot of the mounting systems do penetrate the roof, but with the technology they have today, it's pretty much sealed and guaranteed. One of the biggest things you'll have to do is make sure your roof is serviceable, or has it reached its limits, like a say 25-year roof, and you want to put a solar system on it. You might want to replace the shingles or the siding or the metal prior to installing, because otherwise you'll have to remove the entire solar system in order to repair your roof for the future. This is the ground mounted system. This one has flexibility. It allows optimal, you can actually set the panels in whatever direction you need to get the optimal or the most efficient position. It's easy to maintain. Again, these are at ground level. You can clean those off with ease. If you have to do maintenance to the wiring, you basically just need maybe a step ladder on the backside, and you can do the maintenance on that as well. One of the disadvantages is land use. It can take a significant amount of land to set up a full array like this. One of the other things is wildlife. I mean, it wouldn't be inconceivable of a moose or something to walk up on those things, and so you might want to have to fence it in. That could be another higher cost, and it is a higher cost because now you have to drill into the ground and make sure you have a stable system. But on the good side, it is flexible, and you can actually maybe get more efficiency out of your solar system by having it ground mounted. Here's another option. It's called post mounted. So this one, you get it up off the ground. Again, you have that flexibility of spinning the solar panels any direction you want. You can manually do the elevation, which is basically the angle towards the sun. They're pretty substantial. You can see the concrete pylons in the ground. They're pretty stable in wind conditions. One of the disadvantages is, look at that. I mean, would you want that in your front yard? Maybe not. But if you're saving all kinds of money and powering your villages, that might be the thing to do. Again, installation costs. I went out to a lodge that actually has this system similar to this one and asked about that, because they weren't really using their system because it was installed wrong, unfortunately. But I asked them about how much the post cost, and they told me it cost $10,000 just to put the post in. So there's kind of an expense there. And again, the land use. You're usually precious land space by putting these things in.
Those are the solar panels that are building, Mark.
Awesome. Oh, that's your building?
Yeah. On the left of the picture, but yeah.
Oh, cool.
Mm-hmm.
But yeah, so I actually want to put these into, we have a lodge out there in Dillingham that I want to put a system similar to this in. And the reason is because you can turn them to the the optimal sun exposure during the summer, and then you can actually tilt and raise the elevation on those for the optimal sun in the summertime, which would probably be more flat, and then in the wintertime I can raise them to the position like they are here. That way the snow load can fall off and melt off easily. So that's what I would do with that one. Now this one's a little more expensive. It's probably the most efficient system there is out there. I'm surprised your organization didn't have these. But this one actually follows the sun. It's called a tracking system. You can see it's mounted on a post, and you can see on the backside of the panel it has hydraulics or motors that actually do the turning of the panels to face directly at the sun at all times. This is perfect, but it is expensive. Uh, but one of the things I don't like about this system, and it is a disadvantage, is the maintenance requirements. Especially up here in the northern hemisphere, you got, or actually in Alaska or this in the Arctic area, you have those motors that might not function well in the cold weather. You have moving parts. You're introducing moving parts into the system, and if those go down, it's not fun to try to fix some of that stuff, and you might take a while to even be able to fix it. So your panels might be out of service for a while. So they are vulnerable. So those are the biggest advantages and disadvantages of that system, and it's very costly. So one of the things you need to know before you even start thinking about solar energy is what your actual energy costs are. So this is actually my bill, and what you'll see is that there's a bar graph up there, and the blue line was the previous year, and the black lines or the black bars are this current year. I don't know if you can see that on your slides, but you'll see that the black ones are are actually almost double the size. It's not because I got solar, it's because I have a granddaughter at my house, and this stuff, you can see it actually proves that she uses a lot of electricity in my house. Leaves the lights on, has her hair dryers and things like that. So I just wanted to kind of point that out. But on here, it actually shows my price, my energy usage over time. So this is my actual bill for this past month, I think it is. So that's one of the things you need to understand: your bill, your energy consumption. So I put that in there for a reason, because now we have a little bit of math. So to calculate your home's energy needs, you find out what your average monthly costs are. And I'll pull up this actual chart and we'll show you here. Let me find my picture. Pull this over. So on here, it basically says I use 323.64. So I rounded it up to make sure I turn off the right one here. Let me close that one off. So I rounded up to 324. That's how much my average usage, that's 324 kilowatts per month. So I times that by 12. That's 12 months, and it gives me a total of 3,088 kilowatts. That's my annual energy usage. And then you have to identify your location, and I'm going to show you a quick program here that can be found on PV Watts. And basically what that does, it can generate or show you what your peak sunlight hour is. So this is an average of you'll see on my example here, it's basically 3 hours a day is all the sunlight we have in Alaska. Would you say, oh, the summertime? Yes, you're right. I do get almost 6 hours a day in Dillingham in the summertime. And I think I put that somewhere. And but this is the average throughout the year. So that tells me I need a minimum of 1,000, almost 1,100 peak sunlight hours just to generate or that's how many sun hours I need to generate electricity. So then I calculate the size of the system. I basically say, okay, I use 3,888 kilowatts divided by how many sun hours I get throughout the year. And basically I need roughly a 3.5 to 4 kilowatt. Oh, and then there's efficiencies. So nothing's 100% foolproof. So your efficiencies are your solar panels. It could be the weather, the wiring. Nothing's going to be 100% converted. So you're basically going to lend, and it kind of sounds bad, but you're losing 10 to 25% of your efficiency just by typical use. So I took that 3,500 and I added plus or minus 10 to 25%. And that gave me close to 4,000 watts that I need to generate, or up to 4,500 watts or so. So that's how big the system I need. And this PV Watch can tell you how to do that kind of stuff. And I'm going to pull it up here so we can look at it. I got it somewhere here. So here, this is what PV Watch looks like. You basically, here's Dillingham's zip code. You press go, and it points to where you're at. And let's see here. So this is how much, this is where I got my 3. So basically in January, I do less than 1. And you see in June is my big month at 5.75, all the way down to my lowest month in December, which is getting close to winter solstice. And that's where it's at 0.22. But for the average annual, it's 3.3. And that's what you're trying to do. You're trying to compensate for the entire year, just not your peak sun, unless that's what you want to do. It's up to you as well. And it basically gives you all that information. We could spend an entire couple hours on this program, but basically it's telling you how big your 4 kilowatts. It's telling me you got fixed rack, you got all types of options. Here's your tracking, so it's going to maybe take less. So it automatically figures that out for me. And you'll see here that that's how much electricity I generate. And it gives me a little bit extra down here because of the fact that it's following the sun. So this is how you would figure out your calculate your home needs. So this is what's going to tell you how big your system needs to be in order to be efficient and gaining energy independence. Okay, so here's finance. So there's a couple of things we do for financing. You have your outright purchase is what the corporation did for the solar system I had upriver in Dillingham. Basically, you just purchase it outright. And again, it's already paid for just by the tremendous amount of savings. We saved basically $12,000 for this summer, and next year we'll save $16,000, and the system only costs $12,000. There is also solar loans. And the solar loans are a financial product. That's banks will do this, I guess, or lending institutions. So there's a couple of different types. You got the secured loan, which is basically you put your car up for collateral, or you have some type of investment you can put up for collateral. Often you'll have less interest rates with those. You also have unsecured loans. This is more or less a personal loan. Interest rates are going to be higher, but again, it's a loan which you can manage, your monthly payments maybe with that. And then you also have home equity loans. If you have your own home and you're close to paying it off, you can actually use your home's equity to pay this off. And one of the key benefits is that is you basically don't have upfront costs. You're dependent on the bank or the lending facility. They will pay off your loan. You just got to and that way you can take advantage of the incentives like the 30% rebates and things like that. If you can't quite afford it otherwise, you take the loan out. You own the system, but again, the bank owns that at that point. So you'll be paying that off, and you'll have fixed payments. Some considerations is the interest. They can vary on your credit scores, the amount of collateral you put up for it. And the term of the loan. Generally, you don't want to go past the warranty is generally 25 to 30 years on solar systems nowadays. You don't want to go too far beyond that. I would say you want to pay it off as soon as possible. And then the third one is power purchase agreements. These are probably popular for a business or say I don't know, maybe even an HOA. Which is a homeowners association. Maybe they already provide the panels on your house. You have to purchase as part of that, and you buy the power from them, which is not bad. I mean, the power provider, your local utility we'll just say they charge $1 a kilowatt. but your HOA person can do a power purchase agreement and you're only charging 50 cents a kilowatt. So you can save that way. It's just that you don't own the system. So you're still saving money regardless. So that is an option available to you. So basically how it works is that the developer, HOA or some kind of corporation that owns a series of houses or even just solar panels in general can install the panels. They'll be under their warranty. They'll be under, they'll do the maintenance on it. Just depends on your agreement. The downside of this is that you do not own the panels. And the second thing is you cannot take advantage of the tax benefits from the federal government. That will be the person who's actually performing the power provider in the PPA. So here's some incentives. You got state and local, federal tax credits, and net metering. In Alaska, we're limited in the state specific incentives. With regard to solar installation, but there's still valuable programs out there. In 2024, the homeowner's initial for the federal side is 30% federal tax credit. I know for the one out in Dillingham, they gave us an additional 10%. I'm not sure exactly what that additional 10% was, but so basically we got 40% off with a tax benefit. And it's also you can have 5 years depreciation through corporate. So in 5 years it's depreciated wholly. So again, it's another benefit for the corporation. As long as you owe taxes. So that's the caveat to that. So if you don't owe any taxes, this tax credit does you no good. It's just basically there for you. But if you owe the equivalent of your 30% tax rebate, then yes, you save 30%. One of the examples I have here is, for example, you have a $25,000 solar system, which might not be uncommon, with a $7,500 tax credit. So that means your system only costs $17,500 as long as you have that liability. So net metering. So what this does again is talked about a little earlier is allows the homeowner to earn credits basically. So if you're pumping energy back into the grid, you're getting credits towards your bill. Again, this only goes towards electricity usage. It doesn't go against your the administrative fees and other fees associated with, I'm not sure, it just depends on what your bill says. So mostly that is going to be referring to your net metering credits will go towards your electric usage only. So your return on investment. So the total cost is, well, I've just got this example here. It's a $20,000 system. The 30% tax credit reduces your cost to $14,000. So you have an annual savings. And it also depends on your average sunlight in your location, your size of your system, and the cost of your electricity. So the little example I have here, in this case, for this household, it offsets $1,500 per year in electricity. That's this person's annual savings. An example I use for the off-grid system, I basically save $16,000 a year in fuel costs, and I just can't get over it. I'm astounded at that. So basically, the math for that is the payback period is what your system costs divided by your annual savings. In this case, our system costs $14,000. We divided by our savings of $1,500. So in this case, our $14,000 system will take just over 9 years to pay off. It's not a bad turnaround. So return on investment. So the typical, and this is pretty big, 25 to 30 years on a solar system. And that's like the solar panels. If they go bad of course, with neglect, that's a little bit different, but under normal operating conditions and the way the solar systems and panels are devised, they generally have warranties for 25 to 30 years. So in this example, we again save $1,500 per year. You times that by 25 years. that gives us $37,500 in savings, and our system only costs 14 grand. So that's what we're making off of it. So basically, it's a lifetime savings minus the 14,000 divided by the 14,000, and you have a return on investment of 167% in 25 years. So that's a pretty good investment for something that's saving you electricity. So now we go to the solar process. Once you figured out that you want it and you want to get it installed, so here's what I recommend. You get an initial consultation and a site assessment. So basically that means contact a professional. There's many electricians around here that now are converting to solar. That's what they do. They can come out to your home, or they can actually Google Earth your home, and they can see roof dimensions and things like that, and they can give you a good guesstimate on how much it might cost you. They're going to want to assess your energy needs. That's why you want to have your bill. It's much easier to have a bill in place because that's your actual energy needs than me trying to design something around a cabin that doesn't have an electric bill, because I had to go through and make sure that, we have two refrigerators, a freezer, 24-hour internet operations, lighting for nighttime. There's all types of things you have to take into account, and that's part of your energy needs. So that's what helps you design your system. And again, assess the suitability of your house. That's part of it. So we want to make sure your roof is solid if you're going to do a roof mount. We want to make sure you have the right amount of property so you can understand the aesthetics of what one would look like in your yard. But definitely, if you're going to put it on your house, you want to make sure that your house can support a solar array on top of the roof. Once they get all that information, they'll custom design your system. You can help them out if you want, if you really want to get into it. You're going to go over the estimated costs. They're going to design your system to actually give you what you want. You might only want to pay 50% of your bill, so your system will be smaller, or you might want to pay 100% and provide back to repair the downed grid lines if something happens. Permitting, you got to make sure that if you're within a municipality or some kind of zoning area, that you have the right permits. Otherwise, if something happens, say one collapses or your house catches on fire because of it, you didn't have the right permits, so your insurance might not cover it. Again, consider homeowners associations if you live, or one of the fortunate or unfortunate, depending on how you look at it, to live in one of those areas. Make sure you are complying with those rules. They can fine you for it, obviously. Installation for residentially, I put in here a week, but I actually put the solar system in upriver in a day, not even a day. So it can be done. Mine was kind of a replacement of an existing system, but it can be done. It can be done within a week or so, just depending again on logistics, making sure you got all the right equipment. But once they start the work, you should be done within a week and up and running. But before you can do that, you have to get it commissioned. So you have to have an electrician come out and inspect it. They make sure everything is working properly. And once it's done, your system is activated and you're well underway to be energy efficient and a independent power provider of your own. So here's some useful resources that I came up with. And so in this, you got some solar incentives. You can, these are actually active links, or you can just type these into your computer, and these are different manuals. Alaska Solar Manual. Here's the tax credit guide if you want to enjoy yourself by reading all the tax credits. PV watts calculator, to me, that's a very important tool. It's all kinds of functions. We could spend an hour just going through that entire program. And then solar photovoltaic specification checklist. This is a checklist kind of to design your system that you once you get this installed, or prior to getting installed, this kind of helps you install it. So those are the couple of references I have for you. Other than that concludes my brief, and I am open to any questions.
Yeah, thank you so much, Mark. That was awesome. Great presentation, and I loved hearing about, you inserting your own experiences in there. It's really awesome. So yeah, we'd like to open up the class for questions. Feel free to, raise a virtual hand or unmute or type something in the chat, and we'll get to answering that.
There's a question from Kelly about, I think the panels at CCHRC run in different ways, don't they? Some are automated. Kelly, I think you're right. I'm not entirely sure, but I do think that we have sort of a description of the CCHRC panels on our website if you are looking for more information.
I've got a question for you, Mark. Can you hear me?
Yes.
Yeah, so I know you, so one of the projects you mentioned was the solar project that you worked on for the corporation. And I think you were bringing in some people that hadn't worked on solar before. How was their experience like learning how to install solar for the first time?
They were very excited. So these guys are out of a rural community that we hire on annually to be patrol agents for our organization, and they are very interested in getting solar in their areas. And this was something that they really enjoyed. They had a lot of hands-on. I was able to do some loaner tools from the university out there in Dillingham. So we actually, instead of me just installing it, I went through and explained, we have to torque these at a certain wrench. So we had a torque wrench out there, and I showed them how that worked, how to meter it and gauge it out with the multimeter, show them read the panel, show them how to read it, what they're supposed to maybe get, and depending on your weather. And then we guesstimated what it might be. And sure enough, by doing those and applying the math, and we looked at it and it worked out fine. So we had different types of meters out there. One is called an irradiance meter, the multimeter, amp meter, things like that. So we metered out different aspects of the system itself. And they really enjoyed it, and they're looking forward to taking the actual PV 101 class in the future.
Great. You have a question in the chat. Any recommendations for batteries, type, manufacturer to use in combination with net metering?
I don't personally have any, and I'm not an authority to recommend any batteries. I can tell you I went from the system upriver. We had lead acid batteries. They actually last a long time, surprisingly, but because of the lack of education and maintenance abilities, people didn't understand them quite so well. So we actually melted the terminals on those. So the most recent purchase I did for that application, because it's remote and the batteries need to stay out there throughout the winter time, we got what they call AGM batteries, and those are maintenance free. They don't have to add water to them. Basically, the maintenance on those is make sure they're charged prior to leaving the cabin, and you may have to charge it a little bit before you start them up in the springtime, but they should be they won't freeze as long as you keep them fully charged in the beginning of this or the end of the season. So that's what we have there. In my FedEx van, I converted from AGM batteries up to a lithium battery. Now those have a little bit of a temperature sensitivity. However, they're a lot lighter, so I have to use weight for my FedEx van. So my 3,000 watt battery is the equivalent of only 400 watts of two lead acid batteries, or AGM batteries. So they're heavy, they're like 50 to 75 pounds, and this thing is only 50 pounds for 3,000 watts. So it's give or take on what type of batteries you want. Again, your systems are programmable for all that. But yeah, my personal experience, I think I would probably have a hybrid system, which is basically a grid tied backup, and I would have what you want to do is take your energy use. Say you have a freezer, or something. You find out what energy that generates, and electricity is not down more than maybe a week, usually if it is in Anchorage anyway. I'm not sure in your location, but you take that figure, you say, I want this freezer to run for a week or 7 days, and that's what your battery backup system should be. It doesn't really matter what technology of battery it is, just so that the capacity of that battery can actually do what you want it to do for that length of a period.
Great. And another question in the chat. Can you expand on tips for selecting the right installer? And I also just want to add that I've put the links from your last slide in the chat.
Okay. So I didn't actually cover that, but you want to you can go online and you can, find out solar provider or solar installers. Look at their track record. They actually, a lot of them, a reputable one will actually have a portfolio of what they've done. And you can, like one of my classmates, he's done a lot of stuff in Kotzebue. He's done major installations, and he does everything from uh, small installations to citywide type installations. And he's got a heck of a portfolio. And but that's what you look at. You look for their portfolio, their record, call the people they've installed, uh, make that your decision, but make it an informed decision. Make sure that you just don't just don't hire somebody like me, because I'm not a professional installer. I don't know if I'd go to somebody's house. I would help them in designing or finding the right equipment, but as far as the installation side of it, I don't have tremendous experience other than like for my corporation or my own projects, where my project at home is more of a test bed for different types of stuff. In fact, I went out and got another component today. I'm doing a test out on my van to see if it's more efficient, but that's what I do with it. But you want to get a certified electrician, because that's mostly who they are. And then because they got to be there anyway to certify it when you start dealing with the GridTie stuff. So make sure that that's and there are some solar companies out there that provide packages that basically you just put it on the wall and hook it to your electricity and you're done, because you're not tied into the grid. So just depending on what type of system you want, uh, but definitely do your research. I'm not going to advocate for any certain one, but I would definitely do my research before I had somebody do it, because it can this solar, you say DC, you think batteries, but some of this stuff, it'll reach out and touch you, and you might not be here the next day if you don't do it right.
So thank you again so much, Mark, for being here, and thank you to GVEA for sponsoring tonight's presentation. If you enjoyed this class, again, we have one more left in the Clean Energy series next Tuesday, same time, on biomass energy. And if you want to learn more, you can join our newsletter or visit the website to register. Thank you, everyone, for attending tonight's presentation, and have a lovely rest of your night.